Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ilman. My number matric CN220117. I am from session 2, group 9. We present about our project, which is modulation signal. So this is my group members, which is consists of me and also my other friends, which is Muhammad Hafiz Izzuddin, Muhammad Syamil, Nabil Zikri, and also Muhammad Afiq. For the overview of our project is electronic communication signal form the backbone of modern telecommunication, enabling the seamless exchange of information across vast distance. These signals encompass a diverse range of technologies from analog to digital and are instrumental in powering various communication systems such as radio, television, mobile phone, and the internet. The evolution of electronic communication signals has been marked by continuous innovation, driven by the quest for higher data rates, improved reliability, and efficient use of the available bandwidth. For the introduction, in the realm of communication system and signal processing, modulation signals play a pivotal role in shaping the landscape of data transmission. The process of modulation involves the manipulation of a carrier signal to convey information, enabling efficient and reliable communication across various mediums. This project delves into the intricate world of modulation signals, exploring their significance, underlying principles, and diverse applications. For the next slide, I will pass to my friend. Thank you.
Hi, my name is Muhammad Fib Hasman, and I will explain about methodology. Modulation is a communication process involving the addition of information to a carrier signal by altering its properties like amplitude, frequency, or phase. The primary objective is to enhance information transmission through a communication channel. Modulation yields advantages such as enhanced signal quality, extended signal range, and heightened resistance to noise. This is our circuit diagram. For the circuit diagram, for the amplitude modulation includes a diode, resistor, and LC circuit as shown in the simulation. The carrier signal and the modulating signal are linearly mixed and or algebraically added through R1, R2, and R3, and the mixed signal appears at their common node. This mixed signal is then fed into diode 1 and resistor R4. To rectify the mixed signal, only the forward current from the mixed signal can flow through the circuit. The LC circuit is a bandpass filter whose frequency is equal to the carrier frequency, and the parallel resonant LC circuit in the highest impedance at the center frequency. Therefore, it only allows the AM output, which is a carrier signal and its sidebands, to pass through and pass all the signal to the ground. At carrier resonant frequency, L and C continuously exchange energy, resulting in an oscillation that produces a negative half-cycle pulse for each positive pulse exiting the diode. Amplitude of this negative pulse follow the amplitude of the positive cycles. So in the effect, the AM waveform at the modulator output is complete with positive and negative cycle. That's all for me. I will pass to the next presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq Izzuddin bin Azizi. Uh, so I will continue with presentation for methodology. Amplitude modulation alters the amplitude of carrier signal based on changes in the amplitude of a modulating signal. In a circuit, the carrier signal 10 kHz and 5 volt is connected to channel A, and the modulating signal with 500 Hz frequency and 3 volt is connected to channel B and D of the oscilloscope. The modulation index MI, the ratio of modulating signal amplitude to carrier signal amplitude, is crucial. Distortion arises when MI exceeds 1, causing issues in the modulated signal. The circuit diagram features the carrier signal on channel A, modulating signal on channel B, and the envelope of the modulating signal on channel D. Maintaining MI below 1 is essential to prevent distortion, achieved by controlling the modulating signal amplitude. I will continue with the circuit diagram and uh, simulation result. So as we can see, carrier signal will be connected to the channel A, modulating signal will be connected to channel B, and envelope of the modulating signal will be connected to channel D. And the beside of the circuit diagram is the result. As we can see, the result of the channel D will be over modulation. So that's all from me. Thank you.
My name is Nabil Zikri and I will present our discussion. In radio communication, modulation means combined signals, one of which we want to transmit to radio frequency. It is the process of modifying the characteristics of a signal in accordance with some characteristic of another signal. The information is usually known as the modulating signal, and the high frequency signal, which is being modulated, is called the carrier or modulated wave. Amplitude modulation is the process of changing the amplitude of the carrier frequency in proportion to the instantaneous value of the modulation signal. It is relatively inexpensive, low-quality form of modulation that is used in commercial broadcasting uh, of both audio and video signal. Also, it is used in two-way mobile radio communications. For example, we have citizen band and radio. AM modulator, a non-linear device with two input and one output, modulating signal and carrier signal. There are several types of amplitude modulations. Most commonly used is amplitude modulation double sideband full carrier (AMDSFC) or simply known as amplitude modulation (AM). Other types of amplitude modulation are double sideband suppressor carrier (DSB-SC), double sideband reduced carrier (DSB-RC), and single sideband modulation (SSB).
Assalamualaikum. My name is Muhammad Shamil and I will talk about the conclusion. In simple terms, modulation is crucial for electronic communication, ensuring reliable data transfer. Techniques like amplitude modulation (AM), frequency modulation (FM), and phase modulation (PM) have evolved from the radio era to today's high-speed data transfer. Modulation versatility is seen in methods like PM, FM, and AM, optimizing different transmission channels. Even with technologies like 5G, modulation remains vital for reliability, low latency, and fast data rates, fostering innovation for better connectivity and supporting advanced tech like the Internet of Things (IoT).
For our appendix, we use Google Meet as the platform for our first meeting. Our agenda is Doctor gives two topics for all groups, and we need to select one of the topics, and all the groups need to prepare a report, a poster, and a video presentation of our topic. Our topic that we choose is modulation signal. On this meeting, we discussed the proposal that needs to be done, and we divided the tasks for each member. And for the day 2, also we use Google Meet as the platform, and we do a preparation of a mini report for presentation to our lecturer, and we complete the report and presentation, and then we find information. Each group member find information about the assignment and tasks that were given.